Okay, so let's talk about data.
Yeah.
Sometimes it can feel a little overwhelming, but today we're going to make it fun, I promise. We're diving into those weird, quirky data points that kind of make you go, huh, what's that about? We're talking about outliers.
Outliers, yeah, they're the rebels of the data world, the ones that just refuse to follow the rules.
Exactly. They stick out like a sore thumb. Like imagine everyone in a room is about the same height, give or take a few inches,
Right.
and then suddenly there's this one person who's like 8 feet tall.
Whoa. Yeah, that's going to turn some heads.
Right. You can't help but notice them. That's an outlier in action. But here's the thing. Outliers aren't just statistical oddities.
Nope, they're way more than that. They can actually be super valuable. Think of them like clues, little whispers hinting at something deeper going on in your data.
Ooh, okay, I like that. Like secret messages hidden in plain sight.
Exactly. Sometimes they point to errors like maybe someone messed up a measurement or there was a glitch in the system.
Makes sense.
But sometimes, and this is where it gets really cool, they can actually lead to major breakthroughs. Like, imagine you're a scientist studying animal behavior, and you notice this one animal that's acting totally different from all the others.
Like it's zigging when everyone else is zagging.
Yeah, exactly. That outlier could be a sign of a brand new survival strategy, or maybe even a whole new species.
Wow. So outliers are kind of a big deal then.
Absolutely. But before we can decode their secret messages, we need to know how to actually find them, right? And luckily, there are tons of ways to do that.
Okay, so how do we go about spotting these data rebels?
Well, some methods are really simple, like just looking at a picture.
I mean, like a graph or something.
Yeah. Imagine a bunch of dots scattered across a graph, all clustered together, except for one that's way off in the corner. Bam, that's an outlier.
Ah, so it's like that one friend who always shows up to a party in a totally different outfit than everyone else. Like everyone's in jeans and t-shirts and they're rocking a full-on tuxedo.
That's a great analogy. And those visual methods, like scatter plots or box plots, they're super helpful for getting a quick feel for your data and seeing if anything is really sticking out.
Gotcha. But I'm guessing sometimes it's not that obvious, right?
You got it. Sometimes we need to dig a little deeper and get more precise.
So is that where the math comes in?
You know it. There are some statistical methods like using the z-score or the IQR that can help us pinpoint those outliers with more accuracy.
Okay, those sound a bit intimidating, like something I'd need a calculator for.
Don't worry, you don't need a PhD in statistics to understand the basics. Think of the z-score as a way to measure how far a data point is from the average. The further away it is, the more likely it's our outlier friend.
Okay, that makes sense. So we've got our visual methods for the obvious outliers, and then these statistical methods for the sneakier ones. But what about when things get really complex? Like with those massive data sets where even a Lone Ranger outlier might get lost in the crowd.
You're thinking big picture now. I like it. And you're right. For those supersized data sets, we need some heavy-duty tools.
Bring on the big guns.
Exactly. There are more advanced techniques like Isolation Forest and DBSCAN. They're specifically designed to handle those huge data sets where outliers can be harder to spot. Think of them as super-powered magnifying glasses, helping us zero in on those unusual data points, no matter how massive the data set.
All right, so we've got our methods for finding these outliers. We've rounded up those data rebels. But what happens next? Do we just, ignore them? Do we try to get rid of them?
That's the million-dollar question, and it's what we'll dive into next time. So we've got these outliers, right? These kind of like anomalies hanging out in our data. What do we do with them?
Yeah, it's like we've found these rare birds in our data flock. Do we put them on display, study them under a microscope, or maybe even set them free?
Uh-huh. I like that. Sometimes an outlier is like a misfit puzzle piece that just doesn't belong. Maybe it's a typo, a glitch in the system, a measurement error. In those cases, getting rid of the outlier might be the best way to make sure our analysis is accurate.
So it's like recognizing when an outlier is actually just noise, something that's distorting the overall picture.
Exactly. But here's where it gets tricky. Sometimes an outlier isn't a mistake. It's actually a signal, a valuable piece of information we need to pay attention to.
Okay, yeah, I can see how that could be tough to figure out. How do we tell the difference between an outlier that's messing things up and one that's actually telling us something important?
Well, context is key. Let's say you're looking at customer purchase data and you see an outlier, someone who spent way more than everyone else. Instead of just assuming it's an error, you dig a little deeper and find out this customer is actually a a big influencer who's telling all their followers how much they love your product, suddenly that outlier becomes super valuable. It helps you understand what drives those high-value purchases.
So it's kind of like detective work, right? Like piecing together the clues and figuring out what the outlier is trying to tell us.
Exactly. And just like a detective uses different tools and techniques, we have a bunch of strategies for dealing with outliers in our data. Sometimes we might want to tone them down a bit, smooth out their rough edges so they don't skew our analysis.
So instead of kicking them out of the party entirely, we're just asking them to maybe turn down the music a little.
Haha, I like that analogy. One technique we can use is called Windsorization. We basically cap the extreme values. It's like saying, "Hey, outlier, we hear you, but let's bring you a little closer to the center so you don't overpower everyone else."
Makes sense. Are there other ways to tame those wild outliers without completely silencing them?
Absolutely. Transformations are another powerful tool. Let's say you're working with data that's skewed, with a few really big values stretching things out. A logarithmic transformation can help compress the scale, bringing those outliers closer to the rest of the data without getting rid of them entirely.
Okay, so we can remove outliers, we can tone them down, or analyze them separately. It's like we have different options for interacting with these interesting guests at our data party.
That's a great way to think about it. And sometimes the most insightful discoveries come from focusing on the outliers, treating them as a separate group that deserves its own investigation.
So in some cases, these outliers aren't just guests at our party, they're the VIPs.
Exactly. By analyzing them separately, we might uncover hidden trends, identify unique subgroups, or even gain a deeper understanding of the extremes of our data. Remember, outliers are often the ones that break the mold, challenge our assumptions, and push us to think outside the box.
This is all super interesting, but I gotta be honest, I'm also starting to feel a little overwhelmed. There's so many types of outliers, so many techniques for handling them. How do we know which approach is the right one?
That's a great question, and it brings us to the next crucial step in our outlier adventure.
Okay, so we've talked about how to find these data rebels, these outliers, and we've even looked at some ways to handle them. But it seems like we've been, I don't know, focusing so much on the outliers themselves. Like they're these isolated things. Aren't they really part of a bigger story, like a bigger picture we're trying to understand?
Absolutely. Outliers, they never exist in isolation. They're always part of a larger context, a web of relationships and patterns that we need to figure out. And that's where I think the real skill of data analysis comes in. Connecting the dots, weaving the insights we get from outliers with the overall story our data is telling us.
Okay, yeah, that makes sense. So how do we actually do that? How do we go from just spotting these weird anomalies to actually using them to understand like the big picture?
Well, communication is key. We need to be able to share our findings
Right.
in a way that's clear and compelling, and that's where data visualization comes in. It's like we're giving our data a voice, letting it tell its story in a way that our audience can really connect with.
Right, because I guess even the most amazing discoveries are useless if they're just stuck in a spreadsheet or buried in some technical report, right? You got to bring them to life somehow.
Exactly. Imagine you're trying to explain the impact of climate change to a group of policymakers. You could show them a table full of numbers, but their eyes would probably glaze over. But what if you showed them a dynamic map, one that shows rising sea levels or changing temperature patterns, right? Suddenly the data becomes real, tangible, it has an impact.
Yeah, it's like the difference between reading a boring textbook and watching like a really awesome documentary.
Exactly. One just gives you information, the other one really pulls you in. And so just like a good filmmaker uses the right shots and editing techniques to tell a story, we have to carefully choose the right data visualization tools, the right strategies to present our findings effectively. We have so many tools, bar charts for comparisons, line graphs for trends, scatter plots for relationships, heat maps for intensity, each one with its own strengths and weaknesses.
So it's all about finding the right tool for the job.
Yeah.
The one that best, I don't know, highlights the patterns and insights hidden in the data.
You got it. And it's not just about picking the right chart or graph. It's about creating a narrative, a visual story that guides our audience through the data, showing them what's important, helping them understand what it all means.
So it's like we're data storytellers, right? Weaving together all these threads of evidence, the outliers, the overall patterns, into a story that grabs people's attention.
I love that analogy because in the end, data analysis really is about storytelling. It's about uncovering the hidden narratives in our data, the unexpected twists and turns, the interesting characters, even the outliers who make us question our assumptions, the ones that push us to think differently.
It's been awesome. We've gone from seeing outliers as these annoying data points to realizing they can actually teach us things and even inspire us to tell better stories with our data.
And I hope you've all gained a new appreciation for what data analysis can do. It's not just a technical skill, it's a way to understand the world around us.
So, to everyone listening, the next time you come across an outlier in your data, don't be afraid of it. Embrace it. Explore its story. See where it takes you. You might just discover something amazing that changes the way you see things.